Hello everyone. So today there are many things I would like to discuss, starting with the data frames and the data types. So as you know, there are multiple data types are there, which any programming language that handles. So in the R we have the first one is the numeric, second one is the logical, the true false, third one is the character, the next is the integer, complex is the which uses the complex number, very rarely used, and the raws which are in the bytes. So what this mean is if I run this code is I'm assigning six outline to two different variables. And if you want to check is what the class of x is, we can use the class function and it says it's a numeric value, y is it says the character, and the z it says it's a logical because it's a true. What if we do the concatenation of multiple same type of I'm using the numbers here, I'm combining 6 9 12 into numbers, and what the class return, so it will return the numeric because it will class will return the data type of element of the vectors. So elements here are the numeric, so the number class will also be numeric. What if xyz everything is of different class type? So in the all, what is going to be here the r's, if I run this, so here r was the object in the vector of the same data type. So as you know, there are different, six is numeric, Scotland is character, and the last one is logical. But here r explicitly forcing the object vector to be of the same type, and that comes as the character. So there are different type of tables are available in r, like the data frame. So data frame is nothing but the spreadsheet like view where columns are there, rows are there. Rows are nothing but the observation, and columns are the variables. The next one is the matrix. Again, matrix is something which has the same type, like all the data is either in numeric or some other type. Data frame, it is a mostly used. Data dot table is the enhanced version of data frame, and tbl underscore df is another enhanced version of this data dot table. So let's first look at the first data set, which is our inbuilt world phones. So this is the number of telephones in the various region in our in thousands. So if you want to read about, you can read in the documentation. So let's see what the class of this particular data frame. So it is a matrix type, and if you want to see it, so it's look like something like this. So it's a metric of the same numeric type data. Let's view the different next data set, air quality. So if you see, this is a data frame, and if you want to see the data is in the again numeric, some are values are numeric or not available are also there. And let's look the last one, CM sleep. So it's a class of different type, right? TBL underscore DF. So it's a combination of multiple things. It's a more enhanced version of the data dot table. So it does not matter what type of data set is there. Again, you can convert into whatever data set is you have the requirement of. Like the word for is the matrix, and we want to convert into data frame. We can use as dot data dot frame function, and the name of the data set world point. So if I run this, and now if you want to, if you check the class of this, class of world, so it will be data frame. Similarly, if we want to convert into matrix, we can do that like this. It's now it's converted to matrix. So moving forward is a rainy day in London. This is the character, and if you want to see, it's a character type. So it's a double quote and single quote does not matter. Again, both will have the same type of character. Summation of 1 to 1L plus 2 plus 1L plus 2L. So if we do that, it will be of the numeric type because L also represent the unit and that can be considered as a numeric. So can we do this hello plus 1? No, because the one is the character, second is the numeric. We cannot do the addition. So error is there. No numeric argument to the binary operator. Can we multiply false into 2? So answer should be 0 because false also represent the value equals to 0 and true value equal to 1. So 1, this 2 plus 1 will become 2. So these are some of the inbuilt function of n columns. We want to see that how many columns are there, how many rows are there, what is the dimension, what are the variable names, and rows dot name of mslib is the index. So if we put a column, so it will give 1 to 6, right? 1 to 6 number, and here we can do the represent this x value with 1 to 6 into matrix of 2 to 3. So we can do like this, or if you want to make 3 into 2 matrix, you can do like this. Okay, so vectors in data frame, next topic. Again, we'll look into this inbuilt data type air quality, which is daily air quality measurement in New York in May to September 1970. That's our data set. And let's extract the first, let's assign this data set into our very global environment. And we can extract the data uh, temp vector. So as you remember, to extract that one variable from the data set, we always use the dollar symbol. And if you want to see like this, if you want to get the mean of this, we'll extract this air quality temperature and want to view the mean. So it is like this. This is the command. If you want to use the name of the variables, you can always use name underscore name bracket and the data set. So what this represent here is ij. If I represent here the row and j represent the column. So what this command will do, it will go into this particular data set, look for this fifth row of fourth column, and that will give the 56 value. And if you want to see the complete, right, means if you want to check, this is the same thing what that means. So we are here I'm going for air quality, dollar temperature means fifth is the temperature, right? Here you can see ozone 1 2 3 4, right? And fourth column fifth character, so it will give the same values 56 56. If you want to see everything, uh, fifth row and all the columns, so you can use like this. So absence value means give me everything. If you want to see all the rows for fourth column, you can do like this. And again, this will give the same result. So that means give all everything of the fourth index column. If you want to uh, see all the data in the rows, but want to see like second, fourth, and sixth column only, you can do like this. Combine it, and it will give you all that. You can also use the column name like this. It will give the same result. Here in the air quality, I want all the rows of the third column, right, like this. And we can also perform the correlation function using the same technique. What we have here, give me all the rows. Here we are fourth column and third column, and in the correlation, it's a negative 0.45. If you want to exclude, let's say third, fourth, so we can use minus sign C, 3, 4 like this. So dollar sign again, it is used to accept the variable, but we can also update some data. So I'm just creating a copy of air quality as a data. This is the head means first few observation. Next, I want to extract what is there in the. Uh, as you can see, this value is NA here, right? And sorry, this one is the NA, and I want to update with 22. So what I can do, I can extract that value and run this. And if you want to check it again, so that value has been updated with triple two. Using condition, so we can use the condition like what is the maximum temperature in this air quality data set. We can use max 97, and what is the hottest. So again, uh, we can use which dot maximum, the previous command, so that will give you the 120 is the maximum temperature. And if you want to see the detail of that particular index, so we'll see this command will give 122 index and give me every column name. So these are all the detail. Again, this will also fetch the same result, because what we are saying, give me uh, the index of this, which is the maximum temperature, that means the row, and all the columns. For the lowest, we just have to replace maximum with minimum, and it will give the lowest one. Here, what we are saying, in this particular data set, temperature, which everything is uh, which is 90. Give me that. So this is the result. Next one is some of the logical operators, like A, I'm assigning value to 3 and B to 8. Whether A equals to B, no. A is greater than B, no. A is less than B, true. A is not equal to B, true. A is any, no. A in this number 149, no. B is in this one number, yes. And to get all the indices, we can use this function. So this is what it's going to do is air quality temperature greater than which are the indices. So we can use this command to get all the indices. So here it is giving me false. So what is checking here is, in this particular air quality tree, temperature greater if all the temperature are greater than 90, whether it's checking the condition whether it is false or true, because there are some temperatures are less than 90, that's why I give the false. If there is any means it will check if any of the observation greater than 90, give me true. So it will give the true. If you want to count the number of which has the temperature greater than 90, you can use the summation, and it there are 40 number, right? Why it is giving? Because the false is equal to 0 and true is equal to 1. So if you run this command, so you will see it will fetch, it will compare each and every observation with greater than 90, and will give me a result whether it's false or true. And if you do the summation, only the true value will be 1, and that will summation, it will give the 14. So that's why the above one gave the result 14. To get the proportion again, uh, it will give the mean. And moving next are the and all operators. These are basic, very basic, available in most of the programming language. Whether a equals to b, and if all both the condition are true, it will give true. This is true. Again, or if either of the one condition is true, it will give the true, else false. And XOR is the special one. If true, if false, then it give true, or the other way. I have to check actually. Okay, so find out the coldest day. So which is the coldest day means the less temperature, which dot minimum or less temperature, air quality, give the coldest day. So this is again this the command. If you want to get the in air quality data set, it's wind which is having the value larger than 17, and give me all the values, some values. So there are three values. And what are the three values? You can use this command, means it give it check for the rows and give all the columns. If there is any NA, means the and checking the how many null values are there. There are 37. Combination of two, the 70, and if temperature is less than 70 and wind is greater than 10, you can use this command. Cut is special, again, uh, cuts divides the range of x into intervals and code the values in x according to which interval they fall. The leftmost interval correspond to level 1, and the next leftmost to level 2, and so on. So what is that is convert the numerical data into the categorical data. Moving to next is the importing. So to import the data, there are many ways, And so most of the files data we if we are available are in the spreadsheet, and the most of the extension are .csv separated comma separated files or the Excel file. So for the CSV files, the command is very easy. So read.csv path of your file, like I have this one, and I'm just putting that data into object called data like this, and this is the data. If you want to view the data, this is what it has: six observations. And importing, so this is I'm giving the path, but if you want to browse it, there is an option called file.choose. So if I run this, so that's it will open the browser to select your file. It is other way to import using the RStudio, so you can click on the file, right? Import dataset, and click on this one again. It will open the browse window to import the data. Yeah. So also please make sure that whatever files you are importing, those are available on the correct path. You have to use the different black backslash. So this one has the Macs and the Linux specific. For the Windows, they're mostly the other way. So to import the Excel file, we need to install this additional package of OpenXLS. So I have already done that. So if you want to go ahead, and if you don't have, you can install this one and make it available using the library. And read.xls is used to read the Excel files into Excel file data into R. Saving your files is again, let's say I have this age purchase and I made this data frame using these two vectors, age and purchase bookstore, and I can write this files into uh, so write.csv. I'm writing this as a CSV file, the name of the object and the file name. And if I want to write as the XLS, the name of the object and the file name. So this will save into your current working directory, whatever is it. And if you want to save your whatever you're doing into .r data, like if you have created some model, you can always use the same function, uh, giving your object, your vector, and the file name like this. Oh, sorry, I was selected. Yeah, like this. And you can load whatever files is there, like using the load function. Next, to create projects. So while I'm just showing all the data code into creating a one file, but if you're starting a new project, it's always recommended to you create a new project. So you can go to Files, click on New Project, right? Let me save this one, and it will open a new window, and it will give different option whether you want to create a new directory, if you want to use the existing directory, or you want to create a version control like Git or something. So you can do that. And what kind of project you want to create? You want to create a package, shiny application, or other type of work. So you can do that. So this is the way how you create a new project. Let's do some statistics of running t-test. T-test is used to compare the mean of two different population, and we'll check whether the mean of the two population are equal or not. So we'll use the we'll load ggplot2, and we'll use the msleep dataset where we are first extracting all the carnivorous into one variable and herbivorous into different variable, and doing the t-test of t-dot test of the on the sleep total. So carnivorous sleep total and the herbivorous sleep total. And let's see what's the results. So this gives a lot of information. This is a data set of carnivorous sleep total, herbivorous sleep total. The t-test value is this zero point 0.5. Degree of freedom is 39.31. P-value is zero point 0.5, and alternate 5 is two difference in the mean is not equals to 0. So and 95% confidence interval is this. So we can also change some of the parameters in the t test, like I can reduce the confidence level to 90%. Alternative greater than means creating a hypothesis. It's carnivore is greater than the herbivorous, and the variation equals to 2. And this gives the different different values. P values is different. The degree of freedom has, yeah, it was different. It's earlier different. It's what earlier it was different. Okay, so let's also I will like to show the how to fit a linear regression model. We'll talk into more detail what is a linear regression, but we'll use the empty cars data set. So this is different car models are there, and we have different values of MP mile per gallon, cylinders, all those variables are available. And to do that, let's first see the relationship between the gross horsepower and the fuel consumption, right? So this is the horsepower and this is the mileage per gas, and looks like there is no particular relationship. It's bit down, uh, and let's fit the regression model using the LM uh, function. And if you want to see the summary, so you can use a summary function. It will give a more detailed of what are the coefficient, or if you want to view the coefficient, you can see this. So intercept is the value is this, and the slope is this value. And if you want to add a regression line on this particular, so we can add one more geom AB line. Aesthetic is the intercept value is this coefficient of m first, and the slope is this value. So this is value, and the color red. So let's see. So as you can see, the this is a regression line for these two particular variables. So there are other more plots which you can view. You can use plot.m, and you see there are different. We'll discuss all this later. And next one is the aggregated function. So aggregate function is, if you remember in the earlier, if you try to calculate the mean and there are NA values, so that will give you the NA as the output. But in the regression model, what we are doing here is we are giving saying give us the temperature divided by the month in the air quality and give the mean. So if I run this again, so for month fifth, the mean of the temperature is this. And what is done is removes the NA automatically before running the function. So we can do the same for standard deviation. We can count, uh, do the count, right? Uh, and there is another one more function is there by which do the same thing. It wants two variables, right? The temperature and the month, and it will calculate the mean. It does not look good. I prefer the aggregated on compared to by. Okay, so let's also talk about the pipes. So this particular symbol pipes means it really helps to in the code readability and restructure. What it means if so let's to use this pipe you need to first install this package. I've already done that. And let's say we want to convert the wind into milli per second and then count the means for that group. So to do that, if you don't want to use pipe, then the basic approach is you will create a separate data set. Then you will convert the wind into the milli per second using this formula, and then you do the aggregation to get the mean of that particular group based on the months, like this. Right. So as you can see, the code readability is very complex, and something or the code function is happening from inside out. Means first is calculating this part, right? This part here. Then it is doing this calculation, and then it's calculating mean. There is a better way. So this particular package, aggregator, this introduce this symbols called pipe for the chain function together. So what it does, the it's create the it's calculate the process from like this. So we have a data, we have fast function, and output of this goes into this. output function goes into this, and the final the new variable. So if you want to extract whole day and convert it to millisecond, then compute the grid mean. So how to do that? So if we first load this into the memory, then to start a pipeline, so first we are going to do is load the data, right? This output goes into this next line, agree in the subset. Subset means where we are giving the condition of greater than 80. Then this particular goes into the wind, changing into milli per second, and then group means. And this is what the hot wind means is. As you can see, it's give the same result, but the code readability is better. We know that, how to read the code and where it is finally giving the output to which variable. And it's read from left to right. So if you can see this is how you read the code, and it's where it is storing it. So this is what I have. It's been it's a long video tutorial, and let me know if any questions. Next, we'll dive into more into machine learning and the statistic into more detail in coming videos. Yeah, thank you guys. Have a good one.